Hello, College Algebra, and welcome to 1.2 linear equations in one variable. So we're going to solve some linear equations and hopefully some rationals, and then of course talk about x and y intercepts algebraically, which we kind of touched on section 1. Solving linear equations in one variable, obviously we are trying to isolate x, get x by itself. So naturally, we would subtract b, divide by a, divide by a. Or if you want a more concrete example, 2x plus 4 equals 10. We can get rid of the constant. So 2x equals 6. Divide by 2, x equals 3. The weird thing about this is sometimes you're kind of going in the reverse of PEMDAS. So it can kind of feel like undoing things. You're going backwards in order of operations, but yeah, it's all good. So, for example, we have 3x minus 6 equals 0. Well, we want to add 6. 3x equals 6. Divide by 3. X equals 2. Number 2, minus 7. Negative 2x equals 8. Divide by negative 2, divide by negative 2. X equals negative 4. Here we want to get our x's together, and because they're opposite the equal sign, we can't combine them. So to undo plus 5x, we're going to subtract 5x from both sides. And at that same step, I want to get everything away from my variables. So I'm going to add 9 at the same time there. So 7x minus 5x would be 2x. Negative 9 plus 9 cancels. 5x minus 5x cancels. 7 plus 9 gives us 16. Divide by 2. X equals 8. Here, I would distribute the 6 first, as well as the 3. So I get 6 times x, 6x. 6 times negative 1, negative 6. I still have this plus 4 from earlier. 3 times 7x, 21x. 3 times 1, positive 3. We can combine like terms, so 6x minus 2 equals 21x plus 3. Now we want to get our x's together. I'm going to subtract 6x from both sides. Now I'm just going to write 6x minus 2 equals 21x plus 3 over here for the side for right now. Just leave a little space. And then, of course, I'm also going to subtract 3. So I get negative 5 equals 15x. Divide by 15. We get x equals negative 5 over 15, which can be simplified down to negative 1/3. Now, technically speaking, it doesn't matter which way you move the variables and number values. So I could have subtracted 21x right away, which means I want to get rid of this 2 because now my variables are stacking up on the left-hand side. So I could add 2. 6 minus 21 would be negative 15x. 2 is gone, 21x is gone. 3 plus 2 is 5. Divide by negative 15, divide by negative 15. We get x equals negative 5 over 15, which simplifies down to, again, negative 1/3. So the arrangement doesn't matter as long as you are following good math rules there. Now, rational equations. Remember that a rational expression just means it's a fraction. So something like x plus 4 over x minus 2, or 4 over x, or x over 4. And then remember, when we talk about rational fraction equations, when we're adding and subtracting for least common denominator, we often have to do it in terms of factoring. So the big thing is x minus 2 is all one thing. So if I look at this one, I have x over 3 and 3x over 4. Well, I can break down 4 as 2 times 2, and I can look at my first fraction as just 3. What do I have in green that I don't have in blue? Well, I don't have either of these 2's. So I'd have to multiply this fraction by 4 over 4 so I can get everything on the left-hand side. Inversely, what do I have in blue that I don't have in green? Well, this side is missing the 3. So I'd multiply that one by 3 over 3. And then I can put 2 over 1, and same idea. It doesn't have the blue 3 or either of the green 2's. So I'd have to multiply by all 3 of those numbers. 3 times 2 times 2 is 12. So I'd multiply this one by 12 over 12. And the reason we put 12 over 12 or 3 over 3 or 4 over 4 is I want the denominator, the bottom part, to be the exact same. I have to put it on the top and the bottom. So for example, there in red I have 4 over 4. As a concept, 4 divided by 4 is 1. So I'm going to multiply the first fraction by 1 so it doesn't change its actual value there. That would lead to 4x over 12 plus 9x over 12 equals 24 over 12. And what I can do is I can multiply everything by 12, and that crosses out the denominators and simplifies it out. Here, I just combined that process all into one step. You can just multiply everything by your LCD over 1. That's perfectly fine. But sometimes the structure makes things easier to see that way. Either way, you end up with 4x plus 9x equals 24. Combine like terms, 13x equals 24. Divide both sides by 13. That can't be simplified, so you just leave it as it is. Okay, here, if I break down 9, that would be 3 times 3. Okay, this is just 3, and this one is just 3. So looking around conceptually, the first fraction has 2 3's. It's not missing anything. The green and blue each only have the 1 3. I suppose I put x over 1. So I'd have to multiply the second fraction by 3 over 3 because it needs a second 3. I have a fraction right here that has 2 of them. I'd have to multiply the last fraction by 3 over 3, and I'd have to multiply the middle fraction by 9 over 9. Because it needs both 3's. So that gives me 4x times nothing. So I just get 4x over 9 minus 1 times 3, so 3. 3 times 3, so 9. 9x over 9 plus 15 over 9. I can now multiply everything by 9 to cross out the denominators. I can do this because I'm multiplying both sides of the equal sign by the same value. So you get 4x minus 3 equals 9x plus 15. And then from there, it's just like a problem a couple steps ago. Get all my x's to one side, get everything else away from it. So minus 4x, minus 4x, minus 15, minus 15. We get negative 3 minus 15, negative 18. 9x minus 4x is 5x. Divide by 5, divide by 5. X equals negative 18 over 5. That doesn't simplify, so I would just leave it. If you'd rather do a decimal here because it rounds pretty nicely, I believe that's negative 3.6. That's perfectly fine. If you're in my class, please do not do mixed numbers. So in this case, negative 3 and 3/5. It's just a personal pet peeve of mine. If any of you guys are going to go on to future mathematics, mixed numbers just make things more unwieldy and kind of annoying to work with. So I would just get out of that habit now if you like those. Here, we get 3x over x minus 4. I'm going to put 5 over 1. And here I have 12 over x minus 4. As I talked about earlier, this is a process of factoring, aka multiplication. For example, 9, 3 times 3. Well, that's not what's happening here, x minus 4. So we have to consider that x minus 4 is one thing. It's one factor. So you cannot break that apart. So this one has x minus 4 as its factor. This third one has x minus 4. and this middle one just has the 1. So, as it turns out, all I need to do is multiply this fraction by x minus 4 over x minus 4. And the first and third don't need anything. So, we get 3x over x minus 4 equals, I would distribute the 5, so 5x minus 20 over x minus 4 plus 12 over x minus 4. And then, of course, we can multiply the entire thing by x minus 4, crossing out the denominator. We get 3x equals 5x minus 20 plus 12. That's just going to do -8. We can minus 5x minus 5x. -2x equals -8. Divide by -2, divided by -2, we get x equals 4. Unfortunately enough, though, x is not 4. This problem actually has no solution. So, take a quick look and explain and think about why this problem has no solution here. The reason it has no solution is because if I were to plug in x equals 4 into my original equation, into one of these x's right here, that would give me, 3x over x minus 4 equals 5 plus 12 over x minus 4. And we were to plug in 4 in for this x right here. So this is 4, or this is 4, and this is 4. We get 12 over 4 minus 4, so 12 over 0. The problem is you can't divide by 0, so this creates that no solution. So, recall from the first unit, there are 3 situations you have to look out for. You cannot divide by 0, because these are domain restrictions. You cannot do the square root of a negative, and you cannot have a log of 0 or a log of a negative. So those are the 3 things to look out for. Specifically, I'd probably be focusing on this one because we're dealing with rationals, which involves a lot of dividing and fractions. Next one. Factor everything. So we get x minus 2 is one thing, x plus 2 is one thing, and I would factor the denominator here. This turns into x plus 2 and x minus 2. So, looking around at the problems and the complexion of it, in green, I don't have an x plus 2, which I do in blue and red. So I'd multiply the first one by x plus 2 over x plus 2. In blue, I would notice that green has an x minus 2 and red has an x minus 2, but blue doesn't. So that needs to multiply by x minus 2 over x minus 2. And then in red, there's nothing that green or blue have that red doesn't have. So I don't need to multiply that one by anything. So let's distribute the 1 and the 3. So we would get x plus 2 over x minus 2, x plus 2 equals 3x minus 6 over x plus 2, x minus 2, minus 6x over x plus 2, x minus 2. The order you list them in doesn't matter, so this one has the minus 2 first. It doesn't actually matter. Because you're being multiplied, order doesn't matter in multiplication. Anyway, I can multiply the entire thing by x plus 2, x minus 2, and that's going to cross out the whole denominator. So we end up with x plus 2 equals 3x minus 6 minus 6x. Note that if I had a second thing, for example, if I had the +1, I would have to keep, change, flip that, but I don't, so don't have to worry about it in this case. These are on the same side, so I can combine like terms. Then from there, it's just solving, so we can add 3x, minus 2, minus 2. We get 4x equals -8. Divide by 4, divide by 4, x equals -2. So let's look back at our original equation. Would plugging in x equals -2 cause any issues? And that answer is yes. If I plug it in here or here, for example, in the blue or red equations, so for example, 3 over x plus 2, 3 over -2 plus 2 leads to 3 over 0. So this is no solution. Also important to note that plugging in +2 would have also led to no solution. So we had to be careful for two different restrictions there. And lastly, finding x and y intercepts algebraically. We talked about that earlier, but if I'm looking for an x-intercept, I'm going to put a 0 in for y. So 3x plus 2 times 0 equals 6, leads me to 3x equals 6. Divide by 3, x equals 2. So my x-intercept would be 2, 0, because that's my y value. And if I'm looking for the y-intercept, plug in 0 for x, so 3 times 0 plus 2y equals 6. 0 cancels out, so 2y equals 6. Divide by 2, y equals 3, so 0. 3 would be the y-intercept. Thank you for listening, and I hope you have a great day.